Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 467. In this episode, Scott talks with Dr. Ayanna Howard about making robots smarter.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I am talking with Dr. Ayanna Howard. She is from Zyrobotics, and she has her BS in electrical engineering, her master's from the University of Southern California, and a PhD in electrical engineering, so I am quite intimidated and thrilled to be talking to you.
Thank you. I'm excited to be on the show.
Thank you. Yeah, and you were at JPL also, weren't you?
I was there for, over 10 years, almost 15 years, working on Mars stuff.
Oh, wow. That's pretty exciting. I had the pleasure of talking with, I think, the CTO of JPL recently in, where were we? Somewhere in Scandinavia.
Oh, what did he say?
We talked about kind of the future of technology in a general sense, and where he thinks that if we invest more into space and into Mars, that it will only help us here on the ground. This was Tom Soderstrom.
Yeah, but it's true. If you look at a lot of the research that's come out of the NASA world, a lot of it we use today. I mean, even something as simple as Tango, or as simple as eyeglasses for playing, or golf balls. A lot of things we just assume is like, oh, this is commercial, actually came out of some NASA research.
Have you read this is random, but have you read The Martian? Have you seen this book, The Martian?
No, who is this? Who's the author?
Oh my goodness, let me get the author for you. So this is the best book that I have read all year long, and the author is Andy Weir, Weir, and what The Martian is all about is a theoretical human Mars landing where one of the individuals gets stranded. And
okay.
he has, they just basically, there was a storm and they had to take off and they left him there accidentally. And now he has to survive for 600 or 700 days. And it's completely plausible because it's really focused on the science, like how he fixes the water reclaimer and how he gets potatoes growing in a little greenhouse and, all the little things involved. And all that tech is based on, if they had left anyone else who didn't have a really strong sense of science, he would have been dead.
He would have been, he would have lasted up until the night.
Yeah.
No, that's actually great. So that means it was assumed there was some infrastructure so he could grab some of the technology.
So they've landed, they've set up their tent, they've got the couple of rovers. He also has, interestingly, the other things that they left on Mars over the last 20 years or 15 years. So he goes.
So he got solar panels and he's got some old microprocessors, and he can program up a heater, in fact, because the rovers have internal heaters. Okay.
Right. So, I'm trying to get my non-technical friends to read this, but as soon as they see that it's, he did this many amps through this, and that's too technical. Yep.
Okay.
Absolutely fascinating and wonderful example of real technology on a foreign planet.
Oh, I'll have to take a look at it.
So tell me about Zyrobotics, because it seems like you guys do many, many things.
We do. So Zyrobotics is actually a Georgia Tech startup. So the technology that Zyrobotics focus on is on technology that can impact humankind, primarily individuals with disabilities. And we focus right now on children with disabilities. And so the goal is to take what we take for granted. So if you think about the wording of pervasive technologies, which are tablets and cell phones and computers and things that we just naturally assume everyone uses. If you have issues, if you have physical issues in terms of impairments, it's difficult for you to say pinch and swipe, or if you have any cognitive impairments so that it's difficult for you to focus, or sensory impairments, example, children with autism, this technology, the pervasive technology we take advantage of, becomes difficult to use. So we're trying to kind of bridge that gap between what's already out there and these children with disabilities.
And are these custom machines, or are you making modifications to machines that already exist?
So we design, you can think of it as interfaces. So in terms of the hardware, they're interfaces to, say, tablet computers, touchscreen interfaces, and what technology the child already uses. So as an example, if a child is using a wheelchair, they typically control it with a joystick. So is there a way I can just take my joystick, which I'm very used to using, and hook it up to something so I can use those same motions to now interact with tablet apps? So we're providing the interface between what's already being used by the child and what's already out there, this pervasive technology.
Interesting. When I read about the things that they've done for Stephen Hawking, because he's singular, he gets custom behavior. He gets custom everything. He has his own software and his own equipment. Can you do that for every child, or can you make it more generic?
Well, we have to make it more generic because custom also means very costly. And so these children already have, in terms of medical costs and having to go through therapy, the price that their parents are paying already financially is unbelievable. And so, a child could have a custom solution, but it's not realistic. And so what we're trying to do is create solutions that actually adapt to whatever the ability of the child is.
So that's adapting both in a software sense and then in whatever hardware that you create that interfaces.
Yeah, so the way we adapt, we focus on the software.
Okay.
So we take the hardware, it's generic, it provides, you can think of it as the hardware providing all inputs, so all the possible inputs. And then the software is where you filter it out. You filter out good data from bad data. So we use the software to drive the magic of interaction.
I'm just now getting my kids involved in, little robots, basic stuff. Couple of motors, and I think we're taking a big track. Remember the big track from the 80s, the big, it was almost like a Mars lander, and we're going to plug
yes.
we're going to plug a Raspberry Pi into that. But I'm realizing that I'm speaking from a place of ignorance, so forgive me, but it doesn't feel like a lot has really happened. There's, voltage to a motor, and the motor spins. The motor maybe has a clutch or it doesn't have a clutch, but we're finding ourselves really, the motor doesn't know when to stop, or the robot crashes into the wall. There's so many layers of abstractions that we're missing. Why is that? And why are these robots so dumb?
Because the robots, if you think about the hardware, the motors, and if you think about the research, it's getting it to be lower cost, smaller, more power, more torque. Those issues aren't helping the robot become smarter. What's really making these robots smarter is intelligence, is the software programming. And so if you notice, there's been a lot of issues, I would say drama, about artificial intelligence lately in the news, about how we need to be careful about AI and robotics because, we're doomed to create our own destiny of being eliminated. And why is that? Because if you have robots, if you think about physically, they're functional. They can do things just like us. And if you add the ability for them to be intelligent and think and not run into walls and navigate intelligently and figure out how to do things new, well, then what happens? What happens to these robots that are as functional as us, and maybe can think better than maybe half the population at some point, or learn faster than us? There's this fear that we're doomed to a destiny where there will be no more humankind.
Okay. So tying that back to what you were saying about using the existing pieces of hardware that these children have, it really is the magic of the software that's allowing you to take a basic joystick and, as you said, filtering. Maybe you can talk a little bit about that, filtering the input, because not everyone can simply push forward on a joystick and have it be intentionally forward.
Right. So as an example, if you think about a joystick, movements you call that are uncontrollable, are unintentional. So it might be that I have tremors, or it might be that I want to go forward, but I can only make a little bit of a movement. So just a little bit of if you look at the angles, maybe a 5-degree angle versus someone who is fully capable can do a 100-degree angle. So how do I take that same joystick that's used in different ways and have it say control an application where you can navigate a YouTube channel? So, and that one is, if you think about a YouTube channel, you go in and the functions you need are pretty much some type of search and play and stop, maybe. And so how do you have a joystick that goes from 5 degrees to 90 degrees, give you the same function as, I want to hit the play button?
Wow. Okay. So that is now kind of changing the way that I'm thinking about the relationship with software to hardware, that the hardware really is the smaller part of the problem. It's just how you process those signals, that input from the hardware, that is where all the magic is.
Yeah, the magic is in the software. Hardware, getting it to be robust and reliable is difficult, but making it so that it works intelligently is the software. It's definitely the software.
So that would explain why my robots always smash into the walls, is that I'm simply telling them really basic stuff like go forward, and I'm not thinking at all about getting feedback back from those motors, Right.
We have a saying, garbage in, garbage out. So if you put programming garbage in, you're going to get programmed behavior out.
Absolutely. I will be sure not to tell my children that, but I think you're absolutely right.
No, you have to be very kind with that.
So you've got applications for tablets, and I've seen one of the applications you have coming soon is called the Zumo learning system.
Yes. So the Zumo learning system is a unique approach to this accessibility. So what we found was that younger kids, primarily if you think about a child who's first been diagnosed with a disability, they haven't quite gotten to learn how to, say, control a joystick with intent. How do you start teaching them or training them, having them to do therapy in a way that feels natural? And so kids actually enjoy toys. It doesn't matter whether you have a disability or not. There's something about having the ability to play and to interact with your world. And so Zumo is a device, and inside of it is the same brain as the system that allows you to connect the joystick to the tablet. Same brain. But what we do is we put it into it's basically a stuffed animal where we can isolate movements using sensors so that you can interact with your toy companion, for example, but still interact with your tablet. And so the design of it is that it actually has a joystick design. So as you learn how to move your hand in the forward and backward, left and right direction, you're actually also training yourself how to have intent with, say, for example, a joystick.
Interesting. And then what are the sensors that you're using in the controllers inside there? Is there a brain in there, or are you running that through the tablet or through
No. There's a brain in there, and we use something, you can think of it as a force sensor, force resistive sensor. So equivalent to that. Basically, we're looking at aspects of pressure, which is also filtered out. So if a child has very little, basically they have very little ability to apply a pressure versus a child who can bang away. How do you take that and also convert it into these, swipe and pinch gestures on the tablet?
Are you making generic algorithms, or are you making algorithms that can tune themselves or that a parent can tune?
So right now the algorithms are self-adaptive. So they are taking, and we have in some of our apps, we actually have the ability to learn, basically a learning behavior. So they self-adapt. Now, they don't self-adapt, i.e. you have to tell it, I need you to self-adapt, right now at least. And because we don't want the behavior to change. So as soon as you have it working, we don't want the behavior to start changing because it's trying to improve it unless the parent or the therapist or the special ed teacher wants that. And so you basically have to, so there's where the unintelligent part is you actually have to tell the software, and it's basically just a little button. Okay, I want you to learn. I want you to adapt versus not.
I see. So you improve it, and then you reach a plateau, and you stay at that plateau, so it is reliable and it can be counted on by the child. And then
Correct.
If the child wants to improve again, or if maybe they have regressed in some way physically, then you can relearn and find a new normal.
Correct, exactly.
Ah, okay. In looking through your extensive scholarly works, and it's really amazing. You've worked on such a wide variety of things. One thing stood out to me that I wanted to understand, this term soft computing and soft computing strategies and soft computing approaches. Can you explain that to me in layman's terms?
So soft computing is I would say a field of knowledge that is designed to imitate how people think. So as an example, what belongs in the soft computing world is methodologies such as fuzzy logic. And so fuzzy logic is, if you think about how we drive. So we drive a car, and if you ever had a teenager you had to teach how to drive, you would say, okay, when you get to this corner, you do a hard left, or, you gently step on the gas while you're turning. You use terms like that. You don't say, okay, you need to turn your wheel 20 degrees and press your foot down with a 20 newtons. You don't use that kind of language. You use this very linguistic type of information, and yet we know how to take that and control whatever it is that we need to. Example, a car.
But we know that based on so much context, like context that we're not even thinking about, right? Years of context.
Right. So fuzzy logic, what it attempts to do is it attempts to encapsulate some of this information as a set of linguistic rules. And the engine behind it to take all this knowledge and come up with a valid control methodology. Because at the end of the day, you still have hardware. So as an example, if you have a car that needs to drive based on fuzzy logic, at the end of the day, you still have to provide it a certain amount of volts. You have a certain amount of torque, a certain amount of information. So you still have this linguistic information, but it also still has to be converted.
Ah, okay. And in the context of my world, which is the web development world, sometimes I feel like there's only maybe 3 or 4 layers of abstraction between me and, kind of machine code. Maybe that's overstating. Let's say maybe 6 to 10. You know what I mean? I can get down pretty quickly and see where the assembler is and where the registers are, Right. I have a garbage collector, but for the most part, there's only a few layers. When I'm building large systems like this, systems that have soft computing understanding, are you quite a bit deeper in the call stack? Is there quite a few more layers of abstraction?
Yeah, you're actually higher up in the levels of abstraction. And the concept, and one of the, I would say, critiques about it is that, some people look at it as a black box. So I can define inputs, I can define outputs, and the system itself figures out what's inside. Which
hence the fear. Right?
Yes.
Is that why we're worried about Skynet?
Yes, yeah, because you know what goes in, and you assume that what comes out is what you want, but how that is organized is uncertain, which is also the fear, because it might be organized such that if you get a different set of inputs, it does something you don't want it to do.
So when you worked, and I'm going back a little bit in time here, but when you worked on a soft computing approach for navigating planetary rovers, this is almost 15 years ago.
Yes.
Did you ever find yourself when testing, robots on other planets that, I told it to go over this rock and I don't know why it did that. And then you spend a lot of time debugging, like we have no clue why the rover thought that was a good idea, but it did. Yeah.
And we ultimately figure out why it did what it did.
Because you own the algorithm.
Exactly. I own the algorithm. It's usually because the input was noisy. A lot of times it's because the input was noisy. So what I observed, it was doing the right thing, but what I observed was not compatible with what input it was actually getting, is usually what the reason was. I gave it some inputs that it had no idea what to do with it. So it just classified it as something totally different. And so I'm like, why is it doing that? It's because I gave it garbage as far as it was concerned. And it said, well, I need to do something with this. So I'm going to do what is my closest approximation. So yeah, you could look under the hood and figure it out. But as of course, it's because, I'm designing the algorithm. So I know exactly where to look.
Hey, this is Scott. I like a good community edition. The best things in life are free and the community license from our sponsor, Sync Fusion. will give individual and small business developers access to more than 650 components across 12 platforms, and that includes WPF and Windows Forms, JavaScript, Xamarin, LightSwitch. You can check it all out at syncfusion.com/Hanselman to claim your free license. One of my favorite programmer jokes is that a non-technical spouse says, would you go to the grocery store and buy some bread, and if they have eggs, buy 6. So then the engineer goes and says okay, and comes back later with 6 loaves of bread. And the non-technical spouse says, what did you do? Why did you buy 6 loaves of bread? And the engineer says, well, they had eggs.
Buy 6. Because you prefaced it with the bread. That makes total sense.
It makes total sense, but again, garbage in, garbage out. Like, why did you not if they have eggs, buy 6, for bread. I just run the program. It seems like accessible fuzzy logic for me, for the non-PhD, for the person who's doing a small project. Is this possible? Is fuzzy logic something that I can apply to my robotics projects with my children?
Oh, yes, definitely. Definitely. And in fact, I find that, as long as you are comfortable with them not having to look inside the box, you can totally explain to them how fuzzy logic is used in the much more abstract sense. And so you can create an entire fuzzy logic system. For example, with the robot hitting the wall, a good example is if close to wall, turn left. I can understand that.
Right.
And I have a system where I can say if close. And so then it's like, okay, what is close? Well, let's see. What sensors do we have? Okay, we're going to say close is, 5 centimeters or 20 centimeters. And so that's where you put your human knowledge or expertise in. And then what's left? Oh, left is, anywhere from 45 degrees to 120 degrees. We don't care. We're just going to classify left as this general range. A person who isn't techie can understand how to do that.
And they can understand that this is the inherent behavior, the intrinsic behavior of this robot is it doesn't like being up against that wall. It's going to turn left, and then they'll work around it, and they'll begin to understand it and build that into their designs. Correct. So you have described your research as being centered around humanized intelligence. What does that mean, humanized intelligence?
So my goal with my research and all of my projects is to design robots that can function in our world with us or to help us. And in order to do that, we can't assume that the human is going to change. I mean, they'll adapt a little bit because like touching and swiping, every time you go even to a bank teller, you're like, okay, wait, there's a keyboard? What does this mean? So we have changed our behavior quite drastically.
I'm always so disappointed I can't pinch and zoom on the GPS in my car. I'm like,
yes! It's like, what is this? Why is this not working? So we do adapt to technology. And so that it's not that we don't want humans or people to adapt to robotics, but we don't want to force that. And so therefore the best way to design robotic technology is to design robots that function like people or function so that when they do things, it's intuitive to a person. And so that's this whole concept of humanized intelligence. What makes us as intelligent creatures, what makes us intelligent through our behaviors, through our movement patterns, through what we do. Not necessarily how we think, but the outcome of how we think.
Okay. So these systems, these robots, as you call them, these autonomous systems, they have a path that they're going to go through to get their job done. And you're injecting the human intelligence into that process so that the human is almost a partner to the robot.
The human is definitely a partner. So as an example, if I'm designing a robot wheelchair, as an example, the best way to do that would be have the user operate their wheelchair with whatever device they have and start recording that data. See what their preference are. Maybe they're, a hot rodder and they like to, go really fast. Or maybe they're very slow and cautious, and they don't go out too often. So I can take that information and take the inputs in terms of the sensors and their behaviors and then create a system that mimics that for that one person. So that would be an example of taking how a human operates in the world and creating a control system, a logic system that functions as they do so that when they are in this wheelchair and they're navigating, If something happens, the robot can take over. It's like, oh, wait, hold it. This is a little bit different than what they're normally doing. There must be something that's wrong, or, maybe they're tired and things like that.
So, but when you're saying that you could make a system for this individual, kind of calling back to the very beginning, you can't necessarily do that for an individual, but maybe you could build a fuzzy logic control system that can take recorded input and
right.
adapt.
And it learns for that person. So if you think about the software, the underlying program is the same. What's different is that when you put it on a personalized system, it learns a different behavior. And so my robot is going to be different than your robot because my behaviors are different, but the software is the same.
Interesting. And that is that kind of idea that holy grail of the intelligent agent, where you've had a computer for some number of years and you have, maybe not a relationship with it, but a definite affinity for it.
You have an affinity, right? You have a relationship though. They've done studies to show that, just like you have your car, and a lot of people are just so upset when they have to get rid of their very first car that they ever had, but even if it was a junky car, you do establish relationships with technology, and having a robot is going to be no different.
You just kind of blew my mind there for a second, because you're absolutely right. If you've got your manual my $300 first manual shift car, it had so many problems, but I knew what I needed to do. So that was right. My robot, and I had a partnership with that robot, and I knew how to shift it and when to downshift and how to move it to get it to do what I wanted it to do.
Exactly.
It was beautiful in its imperfection, though.
But you accepted its imperfections.
Well, and I think that's the trick. People have such high expectations of technology now, where if something doesn't work or hiccups, they just kind of declare it, this sucks. That pinch and zoom wasn't recognized, So there's some things we will not tolerate, like lack of reaction to input is unacceptable from a user interface perspective.
Correct. So there are some things we will accept, and there's certain things we won't accept. As an example, I would love it if when I go into my computer and get that little icon that says I'm working, yeah. Could you just tell me why? It could just say, my RAM is a little bit imploded, or, guess what? We're doing a backup in the background that you didn't know about, and that's why. I would love it. I would not be as frustrated if you actually told me the reason why I'm having to wait here. And so I think what's unique about robotic systems is that they can do that. They can say, look, I wasn't trained to do this, or, I'm sorry, I'm about to make a mistake because, I'm assuming A, B, C, or D, or even just saying, I'm sorry. I think those are the things that will make robots more acceptable than, say, my system that just freezes for absolutely no reason, at least I can see.
It's funny. I feel like we're always on the cusp. Like I can see this robot that I don't have yet, this one that doesn't exist, because I can hear him or her in Siri occasionally, like he's in
yes.
there, but he has no body. And then Siri will do something stupid. I'm like, I don't want a stupid robot. And I can see him as I, move my kids' Arduino robots around, but they're not attached to Siri. Have you seen the trailer for the movie Chappie yet?
Oh, yes, I have. Yes.
It's like the return of Johnny Five from Short Circuit.
Yeah, and Johnny Five was an interesting. Yes.
I think that's what we want, though. We want that friend, that companion for the kids, the babysitter, the butler.
That learns, that is a partner, social partner, that's exciting, that's engaging, that caters to your or at least tries to, your every need. I think we do want that. And I truly believe we will get to that point. But it will be very specialized. It's one of those things we say is, that every time we get closer, the definition changes. As an example, if you think about your phone and Siri, if I gave that to you, say 50 years ago, and I said, this is what the future looks like, people would be like, oh my gosh, I can talk to it and it does this and that. Oh, this is amazing. We have arrived. This is intelligent. And now we're like, it's a program. So our definition of, what's grand and what's artificial intelligence and what's robotics changes as we get closer to the goal. And so in one aspect, it's this until we get a chappy. But even when we get a chappy, I think it's going to be it's a little stupid. It has to learn. Why can't I just press the button and it just knows? I think we're just always going to redefine what it is that we want.
It's like Louis C.K. says, everything's amazing and nobody's happy.
Yes, exactly.
Now, I know that you have a passion for STEM and for getting kids involved in technology. I've got little boys, a 7-year-old and a 9-year-old, and when I introduced robots, and by robots I mean, Arduinos and motors, the first thing that they said is, "Oh, we're going to make a robot that will go and get mommy a soda pop and bring it to her." And we've been working on this for a couple of years now, and I just don't have the heart to explain to them that there's so much involved
with getting to that point.
Like, just go over to the fridge. What's the fridge? Like this. We've got it basically so if it starts at a specific place, it can make it there. But if anything goes wrong on the way,
it doesn't make it.
How do you get kids who are excited about STEM, excited about working towards this thing that may never happen? We may asymptotically approach and never reach Chappie without discouraging them.
Well, see, I think there's a difference between what you can do at a certain age and then what's out there. So as an example, there are robots now that I can start it at any arbitrary location and say, go get, and it comes back. Now,
wow.
the cost price is not something that I can buy, but it does exist. There's robots out there that, even not just in the US, but in Japan and overseas, that can grab things and open them and pop a bottle. And you can have it feed people. These things do exist. Again,
wow.
The price point is quite a lot. Even if you think of something as people might think of as simple as Roomba, the vacuum cleaner. And think about it. I have a vacuum cleaner. I can put it in the middle of the floor or not, or I put it in the corner. And guess what? It does one thing and it does it very well. It's like, oh, but it's a vacuum cleaner. But do you know what goes into that to make it so that it's robust and it actually vacuums and it doesn't break down in the middle of the floor and say, I don't know what this cat is. I'm just going to do nothing, just sit here. There's a lot that went into that. And so I think with kids, it's giving them the skills, whether it's the Raspberry Pi or the Arduino to build, but then also showing them. And what's nice about the internet is that all of this stuff is online. It's on videos. People are giving talks about it, but show them is like, look, you keep with this and you can create, the Pepper, which is the new platform that's coming out, Social Robotics. Or you can then create, the next PR2, which is a robot that they were using for assisting individuals. Or you can create. And so I think it's showing them both worlds. It's saying, this is what you can do so that you are prepared to build these great, wonderful things in the future.
I'll put links to all of the stuff that we've mentioned in the show notes here. I'm looking at Pepper here. Pepper is a little small person, maybe 3.5 foot tall, but it's not just a Dalek. She seems to have a waist and she can turn and move in very fluid and very natural ways.
Yes.
Without necessarily going into the uncanny valley.
Right. And if you look at the price point, which is a good link, it's not what I would consider that expensive.
How much is Pepper? I'm looking at pictures. I haven't got to the buy now because sometimes I find things like this and I'm like, where's the shut up and take my money link?
Well, see, unfortunately, they are not selling it in the U.S. But if you go overseas, you're good to go. I think at last point I saw was about 1,900.
Really?
Now I don't know if that was European dollars or U.S.
But still, it's not the $20,000.
No, that's what I'm saying. That's reasonable. That's, times 4 iPhones. That's in the reasonable domain.
I think one of the things that I think is interesting about our conversation here is that, you keep, bringing it back to kind of reality, but I keep going to movies. I feel like I've already recommended movies and books to you I think it just shows the different worlds that we live in, someone with actual robotics experience versus someone whose entire perspective of robotics is filtered through pop culture.
Well, but you know what? I actually watch all of these movies as well.
Okay, good. I don't feel bad then.
No, in fact, I love them. Because honestly, when you watch, I don't read as much as I should, but definitely with the TV shows and the movies, there's always some truth in it. There's always some truth. In fact, you look at it, one of my favorite is Surrogate, with Bruce Willis.
Yeah.
I look at that, I'm like, oh my gosh, if you only knew how close we are to that. It's kind of scary, but it's, you see it and it's like, I know someone who's working on that part and that part and that part. And when they get it to the point where it can be integrated together, we're there. And so I look at these movies because I look at it, I'm like, oh yeah, that exists. So-and-so is working on that. Oh yeah, that exists. So-and-so is working on that.
That's amazing. And you actually know them. You'll be watching a movie and you say, I'm going to call Jeff and tell him.
I saw his stuff. Yes.
That's cool. Yeah. The Surrogate, there's a great book by John Scalzi called Lock In, which extends that concept of surrogate even further. And the movie that I was just thinking about is Robot and Frank.
Oh, that's a beautiful movie.
Isn't it just wonderful? And they actually had a ballerina in the robot to get it to move the way they wanted it to move. A little tiny ballerina was in there.
Oh, that I did not know.
She was about 4'6" or something like that. They had two different dancers in there because they wanted the robot to move human, but robotically human.
Oh, interesting. I did not know this.
That's a wonderful, wonderful movie. I think we'll end on that. And I want to encourage people to check out what you're doing at Zyrobotics, and they can certainly go on Google and search for Dr. Ayanna Howard and read all about some of the amazing stuff that you've done and the products that you guys have at Zyrobotics. Is there anything else I should be sure to point people towards?
No, and definitely if you have kids, encourage them in STEM. We still need it. It's really important, whether it's computer science or engineering or math. I think it's one of the things that we will be in trouble if we don't produce more engineers and scientists.
So there's still room at the top. We should encourage the kids to go there.
Yes, definitely.
Fantastic. Thank you so much, Dr. Ayanna Howard. This has been another episode of Hansel Minutes, and we'll see you again next week.